Hi everyone, this is example 12 from chapter 12 in the student packet. It says a study was undertaken at a certain college to determine what relationship, if any, exists between mathematics ability and interest in mathematics. The ability and interest for 150 students were determined, and the results are in the following table. So I want you to notice that the very first thing I did was calculate the total for each row and each column with that grand total of 150 in the corner. So now for part A, it says, what's the probability the person has a low interest in mathematics? So we're looking at this low interest column, and we have 60 students who have low interest out of this total 150 students. And when we write this as a decimal, we get 0.4. I want you to notice that I'm writing both the fraction and the decimal. The reason I'm doing that is the fraction is showing the work. I'm actually using the values from the table so the reader can see what numbers that I'm picking. But I don't want you to take the time to reduce fractions. That is not what this lesson is about. So put your fraction into a calculator and write as a decimal as your final answer. For part B, it says, what's the probability the person is at grade level? So now I'm looking at the row grade level, and we have 51 out of the 150 students who are at grade level. And this is the decimal 0.34. For part C, it says, what's the probability that the person has a low interest and grade level ability? So we're looking at low interest and grade level ability. But there's only 15 people that fall into both of these categories. So out of the 150 people, only 15 are both low interest and grade level ability. When we put that into our calculator, we get 0.1. For part D, it says, what's the probability the person has high interest or is below grade level ability? So we are going to use the formula. We're looking for the probability that a person has a high interest or below grade level ability. Well, this means I'm looking at the probability that a student has high interest plus the probability that they are below grade level ability minus the intersection of the two. I like this problem because it really shows why we need to subtract off that intersection. So high interest, that's this column, and below grade level ability, that's this row. So the probability of high interest, that's 55 out of 150. The below grade level ability would be 59 out of 150. But notice that these 11 people were counted twice because they're counted in this total of 55 and in the total of 59. And we don't want to count anyone twice. So we subtract them off once so they're not repeated. And when we put this in our calculator, we get 0.69. For part, hold on here, let me erase all this. For part E, it says, what's the probability the person has high interest given the person has grade level ability? So probability that they have high interest given grade level ability. Now there is a formula for this, and you can use it, but I've got a discrete count up here, and whenever I have a contingency table, I find it much easier to just think about this logically. We know that we're given that the person has grade level ability. So I'm only looking at this row because I know that those are the only students I'm considering in this problem, which means the new total is 51. And of those 51 students, I want to know how many of them have a high interest. So I'm going to have 19 out of 51. And when you put this in your calculator, you'll get 0.37. All right, finally, erase my 51 there. Hold on, let me fix that. Okay. Finally, the last question, and I know it's at the very bottom here, it says, what's the probability that interest and ability are independent? So this question is a little bit different from our other independent questions because our other questions asked if two events were independent, and this question is asking if two variables are independent. Each of these variables, interest and ability, have 3 events. You can pick one event from each variable, and it does not matter which one you pick. The only time that we're going to get a little bit worried is if we do this whole calculation and we find that there is independence, then we have to keep going and show that there is independence between every event. But let's see what happens. So let's just choose one from each. I'm going to choose low interest, and I'm going to choose grade level ability. So, and now I'm going to, between those two, I'm just going to pick one. So I'm going to pick, what is the probability that they have low interest? Well, we found that in part A. It's 0.4. And so now I want to see if grade level ability affects this probability. So I'm going to now look at the probability that they have low interest given that they have grade level ability. Well, if they're given grade level ability, that gives me a total of 51 students. And of those 51 students, 15 of them have low interest. And if we calculate this, we get 0.29. And since these probabilities are different, that means that having the ability of being at grade level affected the probability of low interest. And therefore, these are not independent.